Hi, this is Julie Hester, and I want to talk to you about the modulo operator and why do we even care about it? What can it do for us? The modulo operator is shown as a percentage sign, and what it's going to do is it's going to calculate the remainder after integer division. So, here's a case where I'm using integer division and I want to know what is the remainder that's getting dropped. And I can use this for a lot of different purposes. For example, I can figure out if a number is even or odd. So, how do I do that? Well, if you think back to when you learned about even and odd numbers, the way you figure out if a number is even or odd is dividing it by 2. And then, do you have a remainder or not? So, let's look at this. If I have no remainder, it tells me it's an even number. And if I have a remainder of 1, then my number's an odd number. So how does this work with the modulo operator? Well, let's take this flower here. It has 5 petals. I can say 5 modulo 2, it's going to divide 5 by 2, and it's going to have a remainder of 1. So my result is 1, and that tells me that 5 is an odd number. But if I have 2 flowers with 5 petals, I have a total of 10 petals. And now I'm going to take 10 modulo 2, or 10 mod 2, and I'm going to get a result of 0. The result of 0 or no remainder tells me that 10 is an even number. So that's a pretty simple example. Let's look at some other situations where we might use this. Sometimes we want to use integer division. Now, in a previous video, I talked to you about all the problems with integer division and how we might want to typecast one of the numbers as a floating point to avoid integer division. But in this case, I want to use integer division, or in some cases. So if I'm trying to divide up something where I'm always going to want whole numbers, like say dividing up a fleet of cars, I want to have integer division. I don't want to have 4.9 cars. And there's some situations where I do want the remainder. And that's where the modulo operator is going to help me. Well, let's look at an example of this. Let's say we want to divide up a plate of cookies. Now, if you try to divide something like cookies up with children, and you've worked with children at all, you know that they want to make sure that nobody gets more than they get. And so we don't want to give one child more than another. I have 17 cookies and I have 5 children. So how many cookies can I give the children? Well, I can figure out how many cookies to give by using integer division. I'm going to divide 17 by 5. That's going to give me 3 cookies per child. But how many cookies were left over? I'm going to repeat that operation, but I'm going to use a different operator. I have the same operands, cookies and children, but this time I'm using the modulo operator. And what I'm going to get now is an answer of 2. So what that's going to tell me is that if I have 17 cookies and 5 children, then I can give each child 3 cookies, and I'll have 2 cookies left over. Now, what do I do with the 2 cookies? It's probably not possible to take those 2 cookies and evenly divide them up between 5 children. There's no way those pieces will be equivalent, and the children will be upset, so I might just eat the cookies. I don't know. So that's one example of how we can use integer division and the modulo operator. Other things we can do is we can do time conversions. So let's say I have a number of minutes. I can convert that into hours and minutes, or I could have a number of seconds and I could convert that into minutes and seconds, or something like that. And things like time are hard to work with because we're not working with multiples of 10. We're working with weird things like 60s, and we have 12 months in a year and things like that. So let's see how we can do that. Well, first I'm going to start by creating a named constant for the number of minutes per hour. This is a fixed value, it's not going to change, so I'm going to set it up as a constant. Now I have my two integer variables. I'm going to want to figure out how many hours I have, and I'm starting with 70 minutes. And I made this a simple example so that you can do this in your head. And if you have 70 minutes, we can pretty easily figure out that that's going to be 1 hour and 10 minutes without having the computer do it for us. Well, let's see how the computer could figure it out. So the first thing I'm going to do is figure out how many hours I have. I'm going to take my overall minutes of 70, divide them by 60 minutes per hour, and obviously I'm only going to get 1 hour out of that. It's integer division, I get a single hour and I discard the remainder. And that's going to work just fine for calculating the hours. But how many minutes do I have left over? Well, I'm going to do a similar operation here. Again, I'm going to take minutes, but I'm going to say minutes mod minutes per hour. And now I will get the remainder of what I would get with that division. Well, 70 divided by 60 has a remainder of 10. So now I'm going to find out that I have 10 minutes. And if I were to display it or express it, I would see that it was 1 hour or 1:10. Now, if I wanted to calculate seconds and minutes, I would do it in a very similar way, or I could be doing even more levels. I could be working with seconds, minutes, and hours, and so forth and so on. Now let's see how we can parse a number. So let's say that I have a social security number with 9 digits. And when I show a social security number, I want to put hyphens between the different parts. And I'm going to divide it up into 3 parts. So I'll have 3 digits, 2 digits, and then 4 digits. And in order to figure this out, I'm going to alternate using the modulus operator and division to parse this number into pieces. So we're going to start at the right-hand side, or all the way at the lowest place value digits. We're going to start on the back end. And for my social security number problem, the third part of the social security number has 4 digits. So I want to get the 6, 7, 8, 9. I'm going to use the modulus operator to get those 4 numbers by saying social security number, or SSN, mod 10,000. Why 10,000? Because I'm wanting to get where every one of those zeros is one of the digits I'm trying to get. If I were to divide this 9-digit number by 10,000, the last 4 digits would be the remainder, and now the variable 3 would be assigned the value of 6, 7, 8, 9. Now that we have gotten the 6, 7, 8, 9 out of the number, I want to discard them. And so I'm going to use integer division now to get rid of the remainder, or we could also call this a shift, where we're shifting the number over. I want to remove the same number of digits I just extracted. So now I'm going to use integer division again with the 10,000, and I'm going to change SSN's value to SSN divided by 10,000. Once I do that, 6, 7, 8, 9 will be a fractional part. That will be discarded. And now SSN is equivalent to 1, 2, 3, 4, 5. And that's going to be the first 2 parts of the number. So now we need to figure out how to divide that into 2 parts. I'm going to do a similar operation here. I'm going to take my SSN variable and I'm going to calculate mod 100 with it so that I can get the next two digits, the 4 and the 5. That gives me part 2 of my social security number. And now that I have used digits 4 and 5, I want to get rid of them. So I'm going to take the 1, 2, 3, 4, 5, divide it by 100. It gets rid of the 45. It becomes a fraction. And now SSN is equivalent to 1, 2, 3. So for the last part, I've gotten rid of part 2 and part 3. I'm left with part 1. I can just assign 1 to SSN. And now I'll have the value 1, 2, 3. And I can display them all out. I didn't show you the final display, but it would look like 1, 2, 3 dash 4, 5 dash 6, 7, 8, 9. So that's how I can use integer division and remainders with the modulo operator to parse a number. Another thing I can do are conversions, like calculating how many days on Earth it takes to do something. So, how long is a year on Mars? Mars has a longer orbit around the sun than the Earth, so a Mars year is more than one Earth year. But how many days is it? Well, I'm going to look at some constants that I've gotten from NASA, and we're talking about integer values and not the fact that Earth really has a fractional day and we have leap year and all of that. Setting all of that aside, we're going to have 365 days in an Earth year, and we're going to have that it will take 687 days for a year on Mars. Those are both constants. So I'm going to create named constants of type integer. What I want to calculate are the number of days and years on the Earth it takes for Mars to complete a complete year. So to calculate the years, I'm going to take my Mars days, which is 687, divide it by 365. And if you think in your head and approximate that, that's going to be a little less than 2. But how many days are left over? Here's where I'll use the modulo operator. I'll take the Mars days of 687 mod 365. And what I'm going to see when I do this calculation is I have 322 days left over. So for Mars to complete its entire orbit and have a year on Mars, it's going to take one of our years and 322 days for that to happen. So it really is close to 2 years. Looks like it's short by 40-something days. And in my final example, I'm going to show you how you can calculate change for $1. So this could be helpful because it could be that I want to give out some change and I need to figure out how many of each coin to disperse. And the way we're going to do it is we're going to go through this process for each coin. I want to figure out how many I can use of that coin, starting with the quarter, the largest one, and then the remainder is going to be the change that's left over. Once I know how many quarters I need, I'm going to look at the cents that are left over and now calculate how many dimes and then how many nickels. And finally, what's left over will be my pennies. Let's see how we can calculate change for $1 with C++ code. I'm going to begin by creating my variables and my named constants. I have 3 named constants for the value of the quarter, the dime, and the nickel. Then I'm going to have variables to hold the number of total cents, then the number of quarters, dimes, nickels, and pennies. So if I had 63 cents, here's how it would be calculated. The number of quarters that I need our cents divided by quarter. We have 63 cents. How many quarters can we use? And that would be 2 quarters for 50 cents. That's going to give me a remainder of 13 cents. And I'll calculate that by saying cents mod quarter. Now again, quarter in capital letters is my named constant. Quarters in lowercase letters is the quantity of quarters that I'm using. Now that I know how many cents I'm working with, because I've changed the value of cents to be the remainder, I can figure out how many dimes I need. So I'm going to repeat this operation, but I'm going to use the dime constant this time. So dimes is going to be cents divided by dime. Dime is equivalent to 10. And I'm going to take 13 divided by 10. And I'm only going to get 1 dime. How many cents do I have left over now? Well, that's cents mod dime. We know it's 3 because we can do this math in our head. We had 13 cents. We took a dime out of that. Now we have 3 cents left. But if I'm writing this in a program, I might be working with different amounts, and I can't just assume that I don't need nickels. So I'm going to go ahead and calculate the nickels. I'm going to take the cents, that has a value of 3, divided by the value of a nickel of 5. Well, 3 divided by 5 is going to be 0 in integer division. So it means we can't use any nickels here. And again, if I use the modulo operator here, cents mod nickel, I am going to say 3 mod 5. The result is still going to be 3. So in this situation, I'm not modifying the value of cents because I didn't take any nickels out. Now that I've figured out the quarters, and the dimes, and the nickels, I have 3 cents left. And I don't have to do any more calculations to know that the number of pennies I need is going to be the number of cents left over. So what that tells me is if I have 63 cents, then I can make change by using 2 quarters, 1 dime, 0 nickels, and 3 pennies. So we saw several examples of how we can use integer division and the modulo operator to calculate things for us whenever we want to have whole numbers of items or we're concerned with the remainder after integer division.